Now recall an array in C programming language is simply defined as a collection of data values of same data type. Say for example, in C programming language, we declare an array of 5 integers. We would write it this way: int. Say for example, the array name is num and it has 5 elements. So we could declare it this way: num is the array name and 5 is the number of elements, and each element is type integer. So the array is simply a collection or a group of data values. These data values are what we call the elements of the array, and all the elements of the array or all of these data values have same data type. So num is a group of 5 elements or 5 integer values, and these 5 integer values are referenced as num0, num1, num2, num3, and num4. By default, the index of the array starts with 0. So since we start with 0, and if there are 5 elements, then we end with the index, which is size minus 1, where size is this one. Okay, so that is the size or the number of elements or the number of data values. So since size is 5, then 5 minus 1 is 4. So this is the last index. We start with 0 by default and we end with size minus 1. So this is the first integer value or the first element of the array, the second, the third, the fourth, and the fifth. And each one of this is type integer. So this is integer value, integer, 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 and this is also integer. Now in Java, it's also the same. The same is true for Java. An array is a data type that contains multiple data. And you could declare an array of integer either this way or this way. So we have here 2 examples. And on the left side, we have here the syntax to declare an array. And the syntax could be this one or this. For the first syntax, it would be specify the data type, and then you have this pair of square brackets to indicate that it is a one-dimensional array. Okay, a one-dimensional array. And then followed by the array name and of course the semicolon that terminates the declaration statement. Or you could have it this way. So instead of putting these square brackets here, you could put it here. And this is typically how we do it in C programming language, just as our example here. So we could say for data type, int, array name is, say for example, num, and we specify here the size, say 5 elements. Okay. So for the first syntax, our example is this one. Okay. So the data type is integer, and then followed by this, the square brackets, and then the array name is number, and then terminated by semicolon. For the second syntax, we have data type, and in our example, it is int, then followed by the array name, and say our array name is number, then followed by the square brackets and terminator, the semicolon. The syntax to declare an array, as we have discussed earlier, which is given by this part here, or this part here, what we do here is actually just to declare. Okay, this is simply to declare and create an array of the specified data type. So on this part here, we are simply declaring or creating an array of the specified data type. We are not yet allocating actual memory spaces for the array or for the array elements. The allocation of memory spaces in the RAM for the array or the array elements is done on the right side of the syntax. Okay, this part here. So the new operator will allow the allocation of memory or RAM spaces to the array or the array elements. And this one here is the number of elements or the size of the array, the number of elements of the array. Like for example, in here, okay, this first example makes use of the first syntax. So the data type here is integer, and then followed by that square brackets to mean that this array name number, okay, that is array name, is a one-dimensional array. And then we have the assignment operator followed by the new operator that allows the allocation of RAM spaces or memory spaces. And then the data type is just like this one here. It is integer, okay, that is integer, and this is the size or the number of elements. So number is an array or a group of 3 elements, and these 3 elements are number 0, the first element, number 1, the second element, and number 2, the third element. Since the size of the array is 3, and we start with by default 0 index, okay, that is the default index, start index, that's the default start index 0. This is the first element of the array. So the next index would be 1. This is the second element of the array. And the next index is 2. And this is the third element of the array. Now, memory is allocated for the array with the number of elements with default values. So what is done here on the second part, this part here, is the allocation of memory spaces. So what is done on the left side of the assignment operator is just to declare or to create an array with the specified name and the specified data type. While what is done here on the right side of the assignment operator is to do the actual memory allocation of the elements. Now the same is true in here. Okay, another syntax would be this one. So an example to that is the second line here in the example. What we did here in the second syntax is that instead of using the new operator to allocate memory spaces to the elements or to the array, we allocate memory spaces depending on how many elements are listed here. So what we have here are list of values, which are the initial values of the elements. Say for example, in here, we declare an array, a one-dimensional array with the name number, and the elements are of type integer, and these are the initial values of the elements. So we may not specify the size if you have provided the initial values of the elements. So the compiler will know that there are 1, 2, 3, 4 array elements, or the compiler will know that the size of the array, which is this one, this array number, is 4 by counting how many initial values there are in the initialization list. Okay, so we call this the initializer, the list of initial values. So number in this case has 4 elements, And these four elements are number, that's the array name, number 0, that's the first element, second element is number 1, third element is number 2, and the fourth element is number 3. And the initial values of these four elements are, so number 0, the first element, is set to 5. Okay, that's the initial value of number 0, the first element. And the second element, number 1, is set to initial value 1. And the third value here, initial value, is the initial value of number 2, which is the third element. And the fourth element's initial value is 6. So number 3, the fourth element, is equal to 6. So we have here the first element, second, third, and fourth element. Okay, these are first element, number 0 is equal to 5. Second element, number 1 is 1. Third element, number 2 is 0. And the fourth element, number 3, is equal to 6. Okay, so again, this part here, the left side of the assignment operator simply would declare or create an array with that name and with that specified data type. The array is simply declared but not yet allocated memory spaces in the RAM. While in here on the right side of the assignment operator, or here, so you could either use the new operator to allocate memory spaces, which is equivalent to 3 integer sizes without initial values in here, but in here, what is allocated memory spaces are 4 integer types because there are 4 initial values. So the computer will allocate 4 integer type sizes, and the initial values of these 4 elements would be 5, 1, 0, and 6 respectively. We have here another example of declaring an array of string type. We know that this is an array because of that pair of square brackets, which tells us that this is a one-dimensional array of data type string. So the array's elements are of type string. The element type is string. And there are 5 array elements. And these are referenced as, since that is the array name, it would be name 0, the first element, name 1, name 2, the third, name 3, the fourth, and the fifth is name 4. The first element, the second element, third element, fourth element, and the fifth element. Now each of this, each name I, where I is from 0 up to 4, okay, that's the index I of the array name. Each of this is type string. So once you have declared this one, this array of string type, you could later then say in your program, say name2 is equal to 1. Okay, so you assign that string value to this string variable. This is considered a string variable. Each of this is considered a string variable, and so you can assign any string value to each of the string variable. So in the memory allocation, it would look like this. So this is name 0, the first string value, the second string value, third, fourth, and the fifth string value. So again, what happens here in the declaration, on the left side of the assignment operator, what happens is the declaration and creation of the array, and declaring that each element is type whatever is specified here, which is string in this case, in this example. And on the right side, what happens is that the actual allocation of memory space for the array. So again, we call this one here as the index of the array, or the array index. An index describes the position of the element within the array. The index must start from 0. Okay, so 0 is the default starting value of an array index. Now remember, when declaring an array, remember that it has the declaration of the array has two parts. Like, recall the syntax we have last time. We could say int num, and then we say new int 5, right? So this is the data type of each element, and the name of the array is num, and we use the new operator to allocate memory spaces or RAM spaces to 5 elements, so that we create num 0, first element, second element, third element, fourth element, and the fifth element. Okay, so since that is 5, that's the size. We could also say int, and then we have here the square brackets, and then we say num, and then we say new int 5. Okay, we can do that also. So either the square brackets is here or the square brackets is here. Okay, so you can declare an array this way or this way. And you can also, instead of using new operator, instead of just declaring an array num and allocating 5 integer type size memory spaces in the RAM, we could actually set initial values. We could say int and then num. Then instead of new operator, we could set initial values like 5, 2, 1, and 3, for example. So what we create here is an array, a one-dimensional array of 1, 2, 3, 4, 4 elements. And these elements are num0, num1, num2, num3. There are 4 of them. And the first element, num0, is initially set to 5. The second element is set to 2. And the third element is initially set to value 1. And the fourth element, or the fourth integer variable, is set to 3. You can do it this way, you can declare it this way, or you can declare it this way. Now, we can actually separate the first part and the second part of the array declaration, just like what we did here. This is the first part, and this is the second part. Instead of us writing it this way, int, okay, that one, and then the name of the array is foo, and then is set to new int 2, meaning we want to declare a one-dimensional array with the name foo, whose elements are integer type, and there are 2 elements, so it would be foo 0 and foo 1. Okay, the first element is foo 0 and the second element is foo 1. Now, instead of us writing it this way, one line, the 2 parts, the first part, declaration of the array, and the second part, the memory allocation of the array, instead of us having the 2 parts in one line, you could actually separate them. So you could write it this way. Int, okay, you declare the array foo, whose elements are integer type, and then the second part, which is this, will go to the next line. So you would say foo gets new, that's the memory allocation now, new int 2. So in here, you declare the array with the name foo and declare that the elements are integer type. In the second line, we actually allocate RAM or memory spaces for two elements. Two elements because that is specified here. So again, you can separate the two parts in two separate lines. So the first line, we have the declaration of the array, and the second line, we have the memory allocation for the array. And that is exactly what we did here in the example. Okay, this is the first part and the second part. And then on the third line, we set initial value to the first element equal to 2, and the second element, we set that equal to 4. Now, why is this marked wrong? The X here says this is wrong because in this assignment statement, we set this string value, that is a string value, okay, because it is enclosed by double quotes. This is a string value you try to assign to variable foo1, but foo1 is type integer. Okay, so this is type integer and this is string value. You cannot do that. Okay, what you need to assign to integer variable is an integer. So you could write it this way: foo1 gets 2. Okay, this is integer value while this one is string value. There should be no quotation. So again, this is wrong. This line is wrong while this line is correct. We can set integer 1 to integer variable foo0 because each of this is type integer. So this is correct because you assign an integer value 1 to the integer variable, while this one is wrong. That is an error of type mismatch. Now take note also that when an array is declared, its size is fixed. Like in this case, when you specify that that is 2 in the declaration, then this array foo has only 2 elements and it cannot be changed. It is fixed all throughout the program that foo has only 2 elements. Another thing also is that an array element beyond its size cannot be accessed. So since you specify that foo has 2 elements by specifying the size as 2 in here, then there will only be 2 elements, and these 2 elements are foo0 and the second element is foo1. There is no foo -1 or foo2. Okay, so this does not exist. These two, only these two exist. So an array element beyond its size cannot be accessed. So this is correct, this is correct, this is wrong. This is not accessible. It's not accessible, this element here, because as specified in the declaration in here, that foo has only 2 elements. And remember that when an array is declared, its size is fixed. You cannot change that. And by default, the index starts with 0, and therefore the second element is index 1, and so index 2 does not exist. So elements beyond the array size is not accessible. Okay, so this is beyond the array size, and therefore it is not accessible. And when you try to access that in your program, you will get an error.